Okay. Hi all, thank you for coming. My name is Mario Fusco, and I'm the project lead of Drules, which is our rule engine, but I'm also lots involved in some AI-related development as all of us in these days. So I'm recently became a contributor of LangChain4j, and I'm honestly working 80% of my time on it now.
I'm Daniele Zonca, same company, Red Hat, same area, AI. On a different part, OpenShift AI, so the serving capability that you need. So you have a model. If you want to serve it on premise, you need to have the technology and, of course, the hardware.
Okay, so we are speaking a lot about artificial intelligence and machine learning, and we all know how cool it is and how much stuff we can do. And in reality, we cannot even imagine what can we do in 6 months or even tomorrow. I don't know, but. The message that we would like to convey with this talk is mostly that it's all great, it's all really amazing and mind-blowing, but probably we may want still to complement this new tool with existing tool and get the advantages of both worlds. So why not machine learning a lot? Because machine learning is at the end of the day, lots of statistical algorithms that can do amazing things, but still they lack some of the knowledge, for instance, of our business domain. So probably this happened to you, or it happened to me, like I believe last year. I bought a washing machine. And since they are all statistically related, because this is how Amazon works, for instance, Amazon suggested me, okay, you maybe want to buy 3 more washing machines, right? Because they are statistically related, so it makes sense for the machine learning point of view. Of course, it doesn't make sense for us as humans, and it doesn't make sense if you have a very small knowledge about the business domain. While doing everything with machine learning and machine learning alone, you are throwing away implicitly all your business knowledge, which is probably something that you don't want to do, really. And
yeah, so also part of the concern and part of the challenge is that in reality, when we say artificial intelligence, there are many different definitions, many different areas. There is, for example, this classification. There is no single classification, but this is one you can find on many different sources. So artificial intelligence is everything that can some sort of imitate human behavior. Machine learning is more about statistical aspect. Deep learning is more about a neural network. And now, in reality, most of the cases when we say artificial intelligence, we are really referring about the deep learning. But, well, we all use a large language model, or at least that type of technology. And if we really look at the whole picture, it's even more complex. There are like transformer-based architecture, and there is like a field named Generative AI. Generative AI, essentially, if this is the Wikipedia definition, so it's the subset of AI that use generative models to produce text, image, and video, or other forms of data. In reality, let's say, ChatGPT type of model are all based on a transformer-based architecture. So if you see here, there are tons of different flavor and techniques that are all overlapping in some way, so there is no single definition or single classification. And it's important to understand the pros and cons of each of them, because it's essentially they're different tools, and some of them are very, very good and impressive about doing something, but if you use the wrong tool, you can get a very wrong result. So we don't have the time to, let's say, go in deep in terms of, okay, how this kind of model works. Just some sort of simplified definition of transformer architecture has been, most of these, actually, I would say, the whole stream has been created like in 2017, I think, with this paper from Google, Attention is All You Need, that has been, okay, now the technology and the field is evolving a lot, but it's still based on that idea. And the transformer architecture introduced the concept of attention. Attention is like when I needed to produce, so a language model produce new text, so new token based on a previous token. So I have a question, I want to produce the result. The next token is influenced by previous token, for sure, but in human language, not every token, not every previous token has the same importance. And the attention is the constant to say, like, okay, some tokens are more important. So when I need to produce the next one, I need to focus specifically on some of those. And that's more or less the principle. How to compute attention weight. It's not a single dimension. So here in this diagram, to simplify, we say like we have a single, let's say, value, a single weight per token. It's not that trivial, but the principle is like that. If we wanted to imitate, to simulate how humans produce content, this is based on not, let's say, every token that we say. Like now we are discussing, we have started a whole presentation about a topic. You still remember the title, even if we said the title maybe 10 minutes ago, because essentially we put more attention in some specific topic.
Okay, and in reality, yeah, Daniele underlined the distinction between artificial intelligence and machine learning and deep learning, and you know, naming are important, but you know, our work is all made lots of hype more time. So, and the hype is driven by giving fancy naming to things. So I said the project lead of Drools, which is our rule engine, and rule engine were a cool thing in the 80s, and then it weren't cool already when I started doing this around 2000. So we started calling it production system, but even production systems are not cool again. Now in 2020s, everything is artificial intelligence. So we started calling this thing symbolic artificial intelligence. But in reality, we are just trying to give new fancy names to an old technology to make it relevant again in a specific context. And in reality, we are not the only one doing this. I mean, if we see this trend of produced by InfoQ. These are the new branding, new trending technology. And guess what? I said rule engine is technologies from the 80s, but still, if you look into it, you will see automated decision, which is really what a rule engine can do, or even better, policy as code. But you write policy by writing rules. So they are just different applications and different way of using a rule engine, but there is still a rule engine on the ground. So we are just, again, giving new clothes to another technologies, but still it's the same thing. And on the machine learning side, I say that there are a few problems. One of the problems is that by doing 100% machine learning alone, you are probably missing part of your business knowledge, but there are other problems. Of course, the first problem is the accountability. I mean, if something goes wrong, who is responsible for this? Think about driverless car. If this car has an accident, who is the responsible? The owner of the car, the driver, the car manufacturer, the machine learning model provider. We don't know. There is a lack of legislation for this area, but still there is a problem of accountability. We cannot delegate all our decision to this machine learning algorithm, even for a second reason, because often this algorithm has a problem of a lack of transparency. And in some specific area, this is not something that we can give up. For instance, think about if you ask a mortgage to a bank and the bank tells you, no, I cannot give you money just because the machine say no. Okay, this is not a reasonable enough explanation. I believe it's not enough for you. So we have a problem that these algorithms are amazing, but they are mostly a closed box. It's hard to look inside to understand why they produce a result, why they took a decision. And the third thing is probably the most interesting one, under my point of view, is that this algorithm introduce a new category of bugs that we never had before. Okay, think about the traditional bug that you may have in your software. wrote my code, and at some point I made a mistake in an if condition. I put two conditions in end where it was supposed to be an or. Okay, and then I break my head at trying to understand what's going wrong and where the bug is. I debug guard, I find the problem, and I fix it, and I put it in production, and the bug is fixed. Okay, but now if you cannot follow the same pattern with the generative AI in particular. I mean, they produce a result just because you have an hallucination, but there's no way to fix it. I mean, probably you cannot even classify it as an actual bug, because this is simply how the model is supposed to behave. This is how it works. It's not a bug that you can fix. Okay, you can try with different model, you can retrain your model if you have enough money to do this, but it's a totally different thing. It's not deterministic anymore. That's the thing. Okay, and this is just to reinforce what I was saying before. The main idea of this talk is that we want to combine different technologies like machine learning and symbolic reasoning, just because with machine learning it's great to find new pattern, new correlation, but your knowledge of your business domain really lies in the rule engine part. So you code your business with rules, and if you already know your business, and I think you do, you don't want it to be rediscovered again in a much more expensive way with machine learning techniques, and in even probably a less reliable way. Okay, and so far I mixed the concept of generative AI and predictive AI. I'm not going to comment this whole table here, but I wanted to left here for your reference so you can go through this before, but probably this is another important distinction that we need to make. Mostly the most important thing is the output of these two forms of AI. The predictive AI is probably the one form of AI that we know most. It's the oldest one, let's say, even older. It is in terms of, in a very short term of time. It's not decades, okay? But it's the oldest one. So with predictive AI, we try to forecast the results based on a huge data set, while with generative AI, we try to create completely new content, let's say out of the blue, but completely new content by learning from the data set already. And in this case, the data set that is required is much bigger. And they have, of course, different use cases, which is the other important thing. So again, predictive AI is for financial forecasting, fraud detection, and classification, of course, while we started learning right now what we can do with generative AI that are, okay, I see a lots of customer chatbots around. We will have an example about this later, of course, but it's also used a lot now in gaming advertising. And as Stefan demonstrated, it's starting to find its place into software development aid for now area. Let's see what happens in the next months and years, okay? And I'm speaking about also mixing these techniques with symbolic AI or rule engine, if you want. And there is a whole area of research about this thing that is called hybrid artificial intelligence, or even neurosymbolic. And there are lots of documented pattern about how to mix this technology. The name of the pattern are really questionable and not really informative, in my opinion, but there are lots of techniques already on how to do this. And again, one of the example is the last one in this list, which is called neurosymbolics, but with square brackets, don't ask me why. which is the technique of using a rule engine to hide the decision of a chatbot. Okay, and the idea for this, the demo that I'm going to present is. I started a few months ago while I read this news. I don't know if you read something about this. Okay, a few of you. But in reality, what happened is that Air Canada had this chatbot in production to talk with customers, especially about their refund policy. At some point, this customer had an hallucination while talking. This chatbot had an hallucination while talking with a customer. He told the customer that he was entitled to have a refund of 650 Canadian dollars. And this is not really due. It was a totally invented out of the blue policy. Okay. So of course the customer asked for his refund, and of course the airline company said, okay, look, this thing that doesn't exist among our policies, and guess what? The customer took the screenshot of the chat, went in a court, and the judge gave him right, and Air Canada was, of course, forced to pay the refund, and of course the day after the chatbot was off. Yes. This is, again, what can happen if you delegate all your business to this kind of technology. And
yeah, the topic of hallucination, it's like one of the main aspects to look at when you start to adopt generative AI. And it's not like something that we just realized. It's something that is sort of aware since the beginning. But even this is a quote from Google CEO that say like it has no solution for let's say really making sure that the model is fully correct or that the result is it's fully correct. So it's intrinsically is part in these models. And this is, for example, it's like it's like a paper or a publication from Red Hat Research that every quarter does, let's say, some sort of survey. And so the problem and the concept of hallucination is still remain an open question. And there are some idea how to mitigate railing that has been mentioned, like try to make sure that the model is not going to process or produce stuff that is not supposed to do that. Joining, let's say, mixing different techniques, different technologies, so that I'm using, maybe, I don't know, I know that those models are maybe not great at doing reasoning in terms of like mathematical computation, so I use a tool for doing that, and I use the generative AI part just to maybe parse and understand the context. So it's still something that it's like, let's say, the model are getting better. At the same time, this is still remain let's say, in the concept itself of those models, because those models produce new content. There are also publications about like hallucination is inevitable, so it's part of a large language model. So it's part of this mechanism that say like I predict, so I produce the most probable token based on my, let's say, context based on the current situation that I know, but I don't have a way to verify that this token, so this like this knowledge really exists in some way. But this is just an example. There are a lot of research, of course, in this space. And now we start also to, say, use another LLM to verify if the first one is good. Because when we start to look at hallucination, we say, like, OK, but what are hallucinations in reality? Essentially, it's an inconsistency. There are different types. So we can try to classify. A simple way to classify this kind of inconsistency is like, OK, it could be within the output itself. Like, Daniele is tall, Tus is the shorter person. So the sentence itself is an hallucination because it contains two different statements that are in inconsistencies within the same, let's say, the same output. This is a type of hallucination. It's something that, as a human, I can usually recognize that it's wrong, so I will not probably believe the model. Then there might be like between the input and the output. So I'm asking the model, please generate a formal text because I needed to send an email, a very formal email to my colleagues. And maybe the text starts with like Joe Bites or something like more friendly. Okay, this is not really responding, is not compliant with my request. So this is something that even in this case, usually as a human being, I can recognize. But one of the worst case scenario is when you use LLM as a sort of knowledge base. So I'm asking about knowledge. So I don't know something. I ask LLM, can you tell me who was the first moon, when the first man went on the moon? And the model can say, like, well, it was in 2024. If you don't know this information, there is no way for you to verify that, well, okay, this is an hallucination, because it's new knowledge that you don't know. So there are different types of them. And The reason why this is happening, so the fact that this is intrinsically part of the how, let's say, the LLM works, is that, well, one of the reasons is like training data. Those models have been trained on internet, like literally every possible data that you can find. But at the same time, during the training, so the real training, so the foundation training, this is done trying to the model learn how to generalize the concept that are in the data that has been processed for. So, and maybe those data are not comprehensive because new information were not available at the time, so the model cannot learn from those. And this is, of course, a problem because we, as like end user, we don't train those models. It costs really millions of dollars. It takes a lot of time. So we are going to take a model produced by another company, OpenAI, Meta, IBM, Google. So there are this kind of company that produce the base model, and we just use it and consume that. Another part is in the, let's say, those kind of models are hallucination prone. So we want to use those models for creativity. So we want to use those models to produce new content. And there are some parameters like temperature, top K, top P, that are used to constrain the model and say, like, when you created the next token, maybe not take really the most probable one. I want something more creative. So take something that maybe it's like a possible next token, but that has less probability. And so we can, of course, constrain the model to say, like, no, take always the token that you're most secure, that you're more sure about. But you're going to limit the creativity. Most probably, you're going to get boring content that you don't want. You're going to get something that is not what you're looking for in generative AI. So another part is about the context, so the input. So, of course, if you are sending as information, so as a query, information that are, let's say, maybe too generic or too different, like in the same query we are having two different questions that are conflicting each other, the model, of course, gets confused in terms of, like, I don't know exactly what the user was looking for. So it's better to be precise, so not ask generic, do you think that this is good, or like, can you check if this is formal? So you need to be precise in the way you specify the query. So I already mentioned this a bit, so, well, if I cannot trust the output of the model, why don't just ask another model, another LLM to say, like, can you validate that and tell me if it's good, if it's nice, if it's what I was looking for? That it reminds me a bit of the old famous quote about XML, like, it's like violence. If it doesn't solve, just add more. So if a single model doesn't solve, just add another one that is going to validate that again. In reality, if we look at from more like a practical perspective, or even from a theoretical perspective, there is a pattern called LLM as a judge. So I want to use an LLM to judge another output. And in reality, it makes sense because the important part is really asking the right things to the model. So if you're doing a validation, you can try to ask the model to, let's say, analyze what even the same model produced before and see if it's consistent. Of course, you cannot do that for factual checking. Again, the man on the moon, if I don't know this information and the model produced this information, more likely if you're going to ask the model, is this true? The model is going to say, yes, of course, this is what they produced, is what I know, even if it's wrong. But if, for example, in the previous scenario, like the tone, like I was asking for a formal language, is this text formal? This is a very specific question that the model is be able to analyze and say, like, yes or no. Or many other, like, sentiment, like I was asking to be polite, is this answer polite? Or like bias, or like consistency, like I was providing a context. I ask you to do text and summarization. So I'm giving you a text and I want to have a summary. Is the summary based on the original text? So is the answer stay within the original context or not? So those are all techniques where you can really use another LLM to judge the previous one. If you're looking at about the generalization of this scenario, we are essentially going to Agentic AI or AI agent. So where we are trying to say, like, we don't have a single shot scenario. It's not like I do a query and I get a result. I want to compose and I want to get multiple, let's say, situations. So to introduce Agentic AI, there is like, okay, you can say I have data, I have machine learning, and they apply and it's going to produce something. I mean, you can judge the quality. As soon as you add artificial intelligence, everything is better because, I mean, artificial intelligence makes everything better. If you have the generative AI, well, you can start to generate wonderful things, and as soon as you add Agentic AI, start to produce some sort of or not really unreasonable, but you cannot really know what's going on. And as soon as you start to really implement agentic AI system, this is a bit the feeling that you get, because it's the model, the artificial intelligence itself that decide what to do. So let's try to be a bit more specific. What is agentic AI? So agentic AI is more like, it's not different to what we were describing before. It's like we wanted to design a system that use model, data, tool, and make the autonomous decision to say, okay, I have a goal. The goal is like I needed to define the path, the best way to summarize something. I have to reach a specific position. I wanted to process and resolve the claim about who has the fault or who has the entitlement for a refund. So, first of all, agentic AI is going to interact with tool. Symbolic AI or any other external tool can be used to help the model to retrieve the information that doesn't know, to inform the user about what to do. And then LLM can, at that point, decide autonomously the step to say, like, OK, I got the input, understand the question. So first of all, maybe I needed to extract a specific information. Then I need to validate this information. Then I validate the output of the information. So it's going to automatically, let's say, orchestrate in some way. The goal is to have a minimal human intervention so that the model is some sort of autonomous. And at the end of the day, you are combining all the different ingredients. So you have LLM, you have tools that you have symbolic AI, so you have different intelligence, you have different components, you want to compose all of them together. So there are different representations. In agentic AI, in AI agent situation, there are, let's say, patterns now that are emerging to say, like, okay, this is, let's say, the AI agent part has memory, so it's going to, let's say, store and cache the information from the previous step. He has a tool to interact and get information, action to define, and planning, like I needed to decide what to do next to reach the goal. So all of these together produce an agentic AI system.
OK, so this is the theory. Let's try to put this in practice with an example. Of course, your agent can be completely made of AI agent, and in that case, you may have amazing results, but you also may have uncontrolled and not really reliable result, as Daniele was mentioning in one of the former slides. So you want probably to complement LLM, and this is the idea of agentic AI, with other agents that are deterministic and that are specialized to perform a given task. And for instance, I wanted to reproduce the use case of the Air Canada chatbot that I mentioned it before, but this time in a more controlled way, putting a rule engine in the loop. So I wanted to encode with the rule engine the fictional, the policy rules of my fictional airline company, and I encoded these refund rules into a proper rules way. And in reality, I also used the rules for this example also for a second use case, for a second idea, because this chatbot is supposed to collect the data of the customer, and then the data of the flight, the data of the disruption that is suffered, and then it put everything together and send this data to rules to calculate the possible amount of the refund. But when you do this, actually, you are going through different states. So instead of having a very generic LLM that does all this task of collecting all this kind of data, maybe also to reduce the possibility of hallucination, you can have a more constrained and specialized LLM, one that is supposed to collect all the data of the customer, and when all the data of the customer are complete, you can transition. You can have this state machine again. This time has been implemented with rules. And the state machine can transition to a second stage when you are actually using a different AI service that this time is specialized to collect the data of the flight, and then it put everything together and calculate the result. So let's try to give this a try. OK, first of all, probably I can give, I can demonstrate how the code works. So here I collected the rules of my refund policy. So I'm saying here that I'm entitled to have a refund if the delay was bigger than 1 hour. Yes?
Zoom in. Yeah, it needs to be a bit bigger. Also light mode. It's in.
Dove cazzo sta? I don't know how to do this. What?
Like team.
Okay. Yeah. Okay, sorry. I am entitled of a refund if my delay was more than 60 minutes, and the amount of my refund will be $2 for each minute of delay. And in case I'm a senior, in case my age is higher than 65, then I will have the 10% more. So these are really the rule of my of my airline company, the policy that have been encoded in the rule engine. And then here I have that very simple state machine that I mentioned it before. So if I have this object that I call session data that collects all the data taken by the LLM from the customer chat and put it into the session. And if I don't have a customer, I'm still in the phase that I'm trying to extract the customer data. And then I migrate to the second state where I'm trying to extract the flight data. And when I finally have all this information, I can calculate the refund. So these are the two things that I made with the rule engine in this case. Let's give a look at the actual demo. So what you can do with OpenShift AI is having your own model, and you can deploy your model. So you can give it a name and select the kind of runtime that you want to use for this, the size of the server, and so on. And then I put the model that I wanted to use on an S3 bucket. So I can say, okay, my model is there. Then I just use that model and deploy it on this machine. So this generally take a few minutes. So what I'm doing now is that I have a second model here that is being deployed internally in our cloud, and yeah, these are we have this set of models that we have in our internal cloud that we use for internal experiment and development. So I also decided to use the same thing also for my example. So this is the URL where this LLM server is responding. So I just took this thing and configured my application to go to that URL. And of course, I have a key to configure to use with this thing. I can enable some logging if I want. I put the temperature to 0 this time because I wanted to have this thing to hallucinate the lower possible likelihood of hallucination.
Yeah, just a small comment. Yes. The model, it's reasonably big. There is a community online named Hugging Face. I don't know if you're familiar with that. You can find them essentially all the publicly available models. You're not going to find OpenAI, ChatGPT because they are not publishing the model, but many other companies they do. So in this case, it's a Granite 8, so it's an IBM provided model. It's a real open source model. That means that they do disclosure also about which data has been used to train the model. So this is something very valuable. And then, yeah, at that point, you just take the model, you download the model, you make available to, let's say, the cluster. You need to have a cluster with GPU. Based on the GPU, it takes some time, of course, to load, and you need more or less, let's say, resources. And then you are able to have a completely on-premise scenario.
And then I deployed my Quarkus application inside OpenShift, of course. So I have I enabled this route, so it works basically at this URL. Let me paste the URL here. I'm pasting instead of clicking directly because for some reason Chrome decided to rewrite HTTP into HTTPS, and it drove me crazy to understand why it was not working. I have a few examples here, and this is the one that I wanted to show you. So I have this chatbot. I just start saying hi. And now, if you remember, we have that state machine. So I'm in the first phase where the LLM is trying to collect my data as a customer. So it's basically asking for my name and age. Okay. So I can say Mario Fusco. Okay, I missed you. And what's happening here? I provided my name, but I didn't give it my age. Okay, and if you look at the object data requires all this information, okay? Otherwise, it's not valid in my domain, okay? So what's happening here is that I still don't have the complete information of the customer, so I cannot transition into the other state. I'm still in the state when I'm collecting the data of the customer. And by the way, in this state, it is I'm using this service where I'm collecting. I say to the LLM, look, you are collecting the data of the customer. Then I have a second service that will do exactly the same, but instead of producing a customer, will try to collect the flight data. Okay, so I can say, for instance, that I'm 70. Okay. So at this point, the LLM has all the information that are necessary for the customer data. It can finally transition to the second state, and now it's asking information about my flight. I can say that, I don't know, I was on flight number 22, and it had 4 hours of delay, okay? And what's happening now is that it is collecting all this data. So I had, I'm a senior customer since I'm older than 65, and I had 4 hours of delay that are 480 minutes, and it's putting all this thing together and is calculating the thing. But the other thing is that, okay, I said that one of the problems of this generative AI algorithm is the lack of transparency. But the one thing that the use of the rule engine gives you is that it's also auditable. It's also much more transparent what's going on, how it did calculate these things. So what the other thing that I can do is I can say explain why I got this refund amount, okay? And it is telling me the set of rules that have been applied, okay? But how it is doing this thing? In reality, how I configured this thing is that I said to the LLM, okay, look, when somebody asks for an explanation of the refund, doesn't try to invent, doesn't hallucinate, use this tool, and this tool is here. What it does is basically goes on the rules session and asks for the collection of the rules that are fired. So what it's doing here basically is just for now the concatenation of the name of the rules that are fired, which are giving you an explanation of how I come up with that result. So I'm entitled, it is telling me that I'm entitled to have a refund because the delay was more than 1 hour, and the refund is 2 by the 240 minutes of delay, which is 480. And then it's the 10% more since I'm senior, and that's why it's giving me this result of 528. Okay, so it's working I'm combining the nice part of the LLM, the friendliness of the LLM, with the fact that I'm strictly applying the policies of the airline company through the use of a different engine that in this case has been developed with a rule engine. Okay. So yeah, okay. Of course, I took a screenshot of this thing because you never know what's going to happen. So
even with temperature zero,
yes,
you never.
Yes. Okay. And the other thing that I've done, okay, I'm trying different way of combining an LLM with a rule engine. So of course, I asked to ChatGPT, give me a few examples of how this technology could be used together, and of course. The very first result is this customer support chatbot, but there are a lots of other inspiring examples. For instance, I'm quite curious about the smart home automation idea, so you can interact with your generative AI appliances at home that can simplify your life at home, but probably you wanted to stick with some rules, and you can encode these rules with a rule engine, of course. So yeah, I already gave you, I think, the idea of the bottom line of this talk. Again, it's important to understand the different kind of artificial intelligence. It will be good if we stop mixing the names machine learning and artificial intelligence, because they are two really different things, and the artificial intelligence is just about mimicking the human behavior, but it can be done with many other tools that are not only machine learning, but also, for instance, with rule engine. And okay, I already tried to not only mention, but also demonstrate this, that by combining these two technologies, you have a chance to take the good part of both worlds, both the flexibility and friendliness of a generative AI tool, and strictness, and even more important, the transparency that gives you a rule engine in this case.
So the usage of LLM, it's a very powerful tool. It's important that you try to enhance, and you can use LLM for a lot of different things that was not that looks like magic if you compare even with I don't know 3 years ago. The important part is try to not use LLM as a knowledge base. So it's the more likely scenario where the LLM are going to hallucinate. I'm going to ask that's generic knowledge. It's better to provide context. It's better to constrain them in a specific scenario, specify the domain, specify the prompt. And at that point, the flexibility and let's say even the ability of LLM to interact with others makes the solution way more powerful. Agentic AI is essentially a pattern. Well, actually, multiple patterns that are emerging to integrate and extend LLM with everything else, so with other LLM, but even with external tool, so that you can take the best from every technology. From a certain perspective, at that point, let's say Agentic AI, from an invocation perspective, it's application development. It's like at the moment you already maybe have a microservice that make the decision. This decision at the moment is hard-coded in an orchestration layer. Maybe at that point it's going to be LLM based. So it becomes part of your ecosystem. You're going to have some of your services that are AI powered, some other that are traditional mathematical compute analysis or query engine, whatever. You just compose all of them, and you have the flexibility from both of the world. Finally,
okay, and that's all we have. We have some references of this, what we presented today, and that's all we have. Thank you. Yeah. And by the way, if you want to play with this example, the last link is my project on GitHub where I'm experimenting. There are 3 examples at the moment. I'm planning to add more.